Hello everyone, welcome back. This is part 18 of the design patterns tutorial. In this session, we will discuss what is bridge design pattern, implementation guidelines of bridge design pattern, and we'll take a look at a simple example to implement this pattern. Please refer to the previous parts of the tutorial before proceeding. As per the Gang of Four definition, the bridge design pattern decouples an abstraction from its implementation so that two can vary independently, which means the pattern is used to separate an abstraction from its implementation so that both can be modified independently. This pattern involves an interface which acts as a bridge between the abstraction class and implementer classes. By decoupling an abstraction with bridge design pattern, both type of classes can be modified without affecting each other. The bridge design pattern is part of the structural design patterns. As the name suggests, it acts as intermediary between two components. Let's now take a look at the implementation guidelines of the bridge design pattern. We need to choose bridge design pattern when we want to avoid a permanent binding between an abstraction and its implementation, and when we need both the abstraction and their implementation should be extensible by subclassing, and when the changes in the implementation of an abstraction should have no impact on their clients, that is, their code should not have to be recompiled. And we choose this pattern when we want to share an implementation among multiple objects. And last but not the least, we want to hide the implementation of an abstraction completely from clients. Let's now take a look at the representation diagram of bridge design pattern. Bridge design pattern consists of abstraction, refined abstraction, implementer, and concrete implementer. The abstraction defines abstraction's interface, and refined abstraction extends the interface defined by the abstraction. Abstraction also maintains a reference to an object of type implementer, and the implementer defines the interface for implementation classes. The concrete implementer implements the implementer interfaces and defines its concrete implementation. With all this theory, you might be wondering that this is a very complicated design pattern, and I would say that it is certainly not. To make it simple to understand, let's take an example and see why we need to convert that example to implement bridge design pattern. Now let's assume that we need to draw different shapes such as triangle and square and fill them with different colors. Our typical approach would be to create an interface called shape and implement it to triangle and square. Let's say now we want to fill them with blue and green colors. As a typical programmer, we take the next step of creating different classes of triangle and square with colors. Now, if we need to fill them with red and blue color, we create red rectangle, red triangle, blue triangle, and blue square, and red square, and etc. This approach works fine. However, it complicates the extension as things are tightly coupled here, and we would want to decouple the abstraction with the implementation. Let's see how we can represent this using bridge pattern implementation. Now notice that the shape has been moved to abstraction and we have a refined abstraction of triangle and square. Associated with this, we have an interface called color and its implementation of concrete classes which are red and blue. This is a familiar example which is floating around the internet in various articles. However, this example simplifies to understand the bridge design pattern with the representation diagram which we discussed earlier. Now let's switch to Visual Studio and see how we can achieve this using another simple example. To save some time, I have already created a console application. Let's assume that our requirement is to process payment of a customer who has either opted an option of credit card or net banking payment during his purchase process. Now, when I say purchase process, I'm sure that all of you are familiar with a purchase on an e-commerce website where we choose the product and add the product to shopping cart and proceed with the payment. Typically, we are provided with multiple payment options such as net banking, credit card payment, and many more. For this example, let's say we have credit card and net banking as the payment options or the payment choices to proceed with payment. Let's start building our code with a simple interface, which is the implementer in our scenario, and let's call it as iPayment system. The iPayment system will have a method to process the payment. And in order to process the payment, there will be many payment gateways. Let's choose some of the payment gateways as Citibank Payment Gateway and IDBI Payment Gateway. Let's create two more classes. Right click, add new item, and choose a class and call it as Citibank City Payment System. Let's implement the interface iPayment system over here. Now to make it simple, I have copied the things from my notepad. If you notice, City Payment System is inheriting the iPayment system and processing the payment. To simplify the thing, we are just returning the console.write line and printing that this process payment is using Citibank gateway for given payment system. Similarly, let's also create another class and name it as IDBI payment system. Right click on this project, add new item, choose a class and name this class as IDBI payment system. Let me replace this code with the one which I have in my notepad. Notice that I'm implementing the iPayment system and doing the similar step what I have done with the Citibank payment system, except that instead of using Citibank gateway, we are just printing it as using IDBI payment gateway for the given payment system. Now we have created implementer interface as well as concrete implementers for the given interface. Though we are processing payments using different payment gateways, a point to note here is that for the end customer, the only thing that matters is whether it's a net banking or credit card or debit card payment, which means we need to use these payment gateways and bridge them with net banking or credit debit card payment. I hope now you are able to envision why we need bridge design pattern here. To summarize, we have payment gateways that are internal representation to the system and net banking or credit debit card payments which are the higher abstraction exposed to the end customers or the clients. And to maintain this, bridge pattern plays a significant role to connect these things in runtime. Now let's proceed and create those classes of abstraction and refined abstraction implementation, which are our credit card payment and net banking payment. Let's right click on this project, add new item, choose the class and name this class as payment, and this will be our abstract class. To make it faster, let me copy the code from my notepad. Now this abstract class will have an abstract method called make payment. Let's create those refined abstractions to implement this make payment. Let's create a class, add new item, choose a class and name this class as card payment. Card payment is the refined abstraction of the abstraction class. To make it faster, let me copy the code from my notepad. Notice that the card payment is implementing the abstraction class payment. Let's create another class and add new item. Name the class as net banking payment. To make it faster, let me also copy the net banking payment implementation from my notepad. And notice that we are also inheriting the payment abstraction and implementing the make payment method. Now that we have created these refined abstractions and implemented the abstract methods for our convenience and for our representation purpose, I have moved these interfaces and classes to the corresponding folder structure of abstraction, refined abstraction, implementer, and concrete implementer folders. However, it's not mandatory to follow this structure. Our next step is to invoke the corresponding payment gateways in runtime from this make payment method. In order to achieve that, we need to bridge the iPayment system. Based on the representation diagram, the abstraction class, which is the payment in our case, will hold the reference to the iPayment interface, and these refined abstractions, which are net banking payment and card payment, will invoke the interface method of the iPayment, which is process payment. Let's go ahead and implement that. Let's go to the definition of payment and let's create a reference to the iPayment system, public iPayment system, and let's call it as underscore iPayment system. Let's now switch back to the net banking payment and use the underscore iPayment system and invoke the process payment. Let's pass the string as net banking payment. Let's also do the same thing with card payment. Let's just copy this stuff and let's switch to the card payment and process the payment and call it as pass the input string as card payment. Notice that we are able to bridge the interface and decouple the abstraction implementations. Let's see how we can use them in the client, which is the main program in our case. Let's switch to the main program. Let's say a customer is doing the payment using a card payment. So let's create payment and let's call it as an order equal to new card payment. Now, depending on the payment gateway's availability, we are going to process it through respective payment gateways. Let's say in this case, we have Citibank payment gateway available. Then let's say order dot iPayment system, which will be decided in runtime, equal to new Citi payment system. That means Citibank payment gateway is available, highly available at this moment. So the payment will be processed through the Citibank payment gateway and the customer will be making the payment through this payment gateway. Hence, we will invoke order.makePayment. The make payment internally will assign the Citi payment system and will invoke the Citibank payment gateway. Let's run this application and see the output. Notice that the application says it's using Citibank payment gateway for card payment. Similarly, we can assign the IDBI payment system based on the availability. Now let's say we have IDBI system available in runtime. So the simple way to decouple is to create a new IDBI payment system. And let's run this application again. Notice that we have IDBI payment gateway for the card payment. Now let's do the other way and switch the order to use the net banking payment system. So let's say payment order equal to new net banking payment. The iPayment system could be still be used as Citibank payment gateway in this scenario. Let's run this application and see the output. Look at that, we are using the Citibank payment gateway for net banking payment instead of card payment. Let's stop this application. I hope now you are familiar on how we have decoupled the abstraction from its implementation. With this, we have successfully implemented the bridge design pattern. Thank you for listening and have a great day.